All right, we are back with some special guests. These are my kinds of people because we're going to be talking about machine learning and AI and cognitive stuff. I'm pretty excited. Why don't you introduce yourselves, tell us who you are and what you do.
Sure, Seth. So, Val Fontama, I'm a principal data scientist manager over in Azure.
Fantastic.
Shawndra Hill, I'm a senior researcher at MSR NYC.
See, we're going to get the knowledge right now. So for someone, because everyone's hearing about machine learning nowadays, how would you describe machine learning to someone that wants to understand how to get started? We'll start with you, Shawndra.
So in terms of how to get started, I think there's so many ways to get started. Obviously, you can get a degree in computer science, but there's so many data sets now out there online and so many Coursera courses that sort of get you to the basics that really anyone who has the interest can start with a data set. And Microsoft now has solutions that have democratized machine learning. So I think the first start is to sort of have a problem you want to solve, find a data set, and then start applying the algorithms.
Awesome. Val, what do you say?
Yeah, I'd say in a nutshell, machine learning is a set of algorithms that you can apply on your data to get insights, right? The key difference from BI is they tend to be forward-looking. They tend to be algorithms that allow you to project forward instead of just looking backwards.
I see.
And just to add to what Shawndra said, there's so many different ways you can get into machine learning now. So in addition to the MOOCs and certification programs, many universities are now running either postgraduate certificate programs, and I actually teach one at UW. Shawndra used to teach at Wharton School as well, which is really good.
Yeah.
And then many more are actually running formal master's level or PhD programs.
So let's talk about, okay, so let's just say someone has a rudimentary knowledge of math. Do they need to be super mathy to get how these things work? Or to be a good data scientist, obviously you have data, but then how do you know which algorithm, for example? Like you hear about deep learning nowadays, but then maybe 10 years ago it was SVMs, and then 10 years before that it was neural network. I mean, how do you see what I'm asking? I'm I don't know what to do. So we'll start with you, Val, and we get to you.
Sure.
Okay, so I will not lie. The math is important, but is it a deal breaker? No, right? You can go a long way without doing hard math. I think the hard math becomes more important if you want to design your own algorithm or if you want to truly debug existing algorithms. But you still need a basic understanding of math because you have to understand how these algorithms work, at least at a basic level, right? Otherwise, you'll just be throwing things at the wall. You'll just be throwing data and hoping for the best. But that said, I said you don't need to be a master's level or PhD in math to do this. So the second part of your question is how do you know which algorithm to use? Well, that's part of the thing you learn through whether it's certificate program or even the MOOC programs in machine learning, because the good thing is machine learning offers a large menu of algorithms. But I think of it like tools in a toolbox, right? You need different tools for different jobs. It's always tempting to use a hammer for everything, and that's why they say when you have a hammer in the hand, then everything around you looks like a nail.
That's right.
Right? But you end up abusing the algorithms. They're a good set of algorithms that are designed for specific types of problems. And part of a good machine learning training program is to help you sort it out, right? It will show you, if you attend my class or Shawndra's class, for instance, you will learn the basics of, okay, here's what each of these tools are, here's how they work, here's where they work best or not.
That's awesome. Shawndra?
Yeah, great. And sort of just to add on to what Val said, I would say a lot of it has to do with the problem that you're trying to solve and also the data that you have to solve that problem, right? So depending upon what your data looks like, you might pick one algorithm versus another. So really understanding how to, first look at the data to understand, do I have numeric features? Do I have text features? Do I have categorical features? How are they distributed? To a large degree of the choice, it relies on sort of what data you are trying to learn, and then maybe more importantly, what objective you're trying to reach. So for instance, if you care about accuracy, maybe you would sort of pick a neural network or something that, tries to optimize for that. But if you're, you're just trying to learn something and you need something that is comprehensible, that you can explain, right? There are methods for that too. So it's really important, as Val said, to understand sort of when each algorithm will give you the results that you need to actually do the job that you're trying to do.
So that brings up the next question. How much of this is like you look at, because obviously you start with a question, and then you see if you have the right data.
Right.
How much of is it like horse sense of like, okay, I'm looking at this, I'm going to try this, this, and this, and then obviously it never works the first time. I don't know if people know this, but the majority of time things never work the first time.
Right.
But then there's like this horse sense of like, okay, now I'm going to do this.
Yeah.
How do you, is it just experience? Is there some tips you have with that? Because to be honest, every time I've done machine learning, it never worked the first time, and then it got iteratively better as I tried different things and did other things. What do you suggest for that?
Yeah,
Shawndra?
so I think you just answered the question. I think a lot of the sort of speed comes from, or being able to do things quickly, comes from experience. So both experience with the algorithms and also experience with not just different data sets, but thinking about problems. Like, how do I frame a question such that I can actually answer it, right? And so that sort of skill is really important, maybe more important than actually knowing how to push a button and run the algorithm. Students sometimes really struggle with asking the right questions, and you could teach them how to use tools and push the button, but actually being able to formulate questions in a way, and that does come with experience, I think.
Yeah, and just to layer on that, right? That experience is no different from the influence of experience in other professions. Just like a good surgeon or a good businessman, right? Over time, you tend to build some internal pattern recognition about what problems would work well with, or what algorithms would work well for which types of problems. And in fact, that's one of the things that separates a more seasoned data scientist from a novice, right? Because if you're if you're a seasoned data scientist talking to a client about a problem, while they talk, you're trying to figure out a mental model. What type of problem? Because for me, the first thing is I'm trying to figure out what type of problem is this. Is it a propensity problem? Are we just trying to predict, the odds of a given outcome? Or is it something else? Are we trying to cluster customers in a different way? Or could it be an optimization problem, right? So a lot of that comes with experience. You tend to reason with the problem, and you can quickly find the right bucket, the right category for it. But even for a novice, I think something else that really, really helps is the training, because most decent training programs will break down the process for you. There is, in fact, there's not just one. There are multiple good processes for doing machine learning effectively, right? Like, back in the day when even before I think around the time I did my PhD, there was a new process called CRISP-DM for data mining that still applies today. One of the key parts of most of these processes is the emphasis on feature engineering. That's really important because historically we've found that it really pays to explore your data intimately before you start applying machine learning algorithms, right? When you do that, you're more likely to end up with more powerful, more predictive models. And so we always drum that into our students' heads to make them more proficient. It's only recently with algorithms like deep learning that that mantra doesn't apply as much.
Oh, because it does automatic feature selection in the
Correct.
Right?
Yeah.
Shawndra, you're going to say something?
Yeah, I wanted to add a little bit to what we just said. So I think, too, something that shouldn't be discounted is the role creativity plays in actually doing this type of work. So, of course, you need to know the machine learning algorithms, but because feature construction is such an important role, and in fact, when you see, companies or solutions kind of leapfrog with has already been done, it's usually not because of new algorithms, but because somebody introduced a new feature, either because they've combined data in new ways, or because, maybe even somebody who's not a data scientist said, well, why don't you try, this feature, and see if it works. And so creativity actually plays a huge role, I think, in success of models in practice.
So this is an awesome discussion. You mentioned questions. Some people have this notion of let's just throw machine learning at it and it's going to be magical and work. Are there only specific questions that machine learning can answer? And if they are, what are they? Do you see what I'm asking? I mean,
Yes.
can you just say machine learning do this and it'll do whatever? Or are there specific things that it can and maybe can't do?
Yes. So there's certain, just like with any tool, as I said, any tool has its strengths and weaknesses, right? Machine learning is not a panacea to all types of problems. I always joke that machine learning will not solve world hunger.
No.
So there's certain classes of problems that are very, very open to machine learning, right? If you think about propensity models, for instance, how do we find the best customers for a given product? That's a well-beaten path for machine learning models. How do we build models to do cross-selling, right? Again, through recommender systems, that's well proven. But machine learning is not good for all, or at least it's not the best solution for all types of problems. One case in point is optimization. Optimization is, I'd argue, among the harder classes of problems to solve. And whenever people come to me with optimization problems, once I figured it out, I'm not really leaning on machine learning because there's a whole discipline called operations research that offers very, very powerful tools for optimization.
Shawndra?
Yeah, so I guess I would add to that machine learning tends to work well, not just for sort of certain types of problems, but for problems for which you have data, right? So a lot of times,
that's
so a lot of times, people will be like, oh, can you tell me, where I should invest, right? And it's like, oh, well, have you invested before? No, it's a new product, or I'm trying to open new stores, and they have no data, right? So if you have no data, you can't build a machine learning model, right? So that's kind of one aspect of things. I do want to mention, and it's something that came up in our session earlier, you have to still be careful, even if you have a lot of data. We don't want to forget that sometimes data because it's observational, will have inherently some biases in it, right? And so there's a whole field of, or I would say subfield of machine learning that's a burgeoning one, that's focusing on fairness and accountability and trust in machine learning to make sure that whether the biases are coming from the data or the algorithms or something else, that we are paying attention to the fact that these algorithms can discriminate and do things that maybe even are unethical.
And that's absolutely true. And it's important to know that the computers aren't being that way. It's like you either give it data of a certain kind of people, or your algorithms are only selecting for a certain kind of, that might be a bad idea as well.
That's right.
So when you do your doctorate, you usually focus on a specific thing. I've been curious to see what was your specific focus. We'll start with you, Val.
So are you asking about my favorite
your specific focus, because when you're a PhD student, you focus on like one, you get this mountain of knowledge to get to this one little tiny point at the top, and then you write a big dissertation, right? Tell us about what was it that you studied specifically?
Yes, for me, for my PhD, I did vision. But
that's fun.
It was a very interesting application of AI and machine learning, because I was actually solving problems in mechanical engineering.
I see.
I solved two key ones, but let me talk about one in the interest of time. For my thesis, I used machine learning, specifically neural networks, to measure the velocity of fluid flow. Curious thing is, even back then, that problem was being addressed using established numerical techniques, like engineers would use finite elements or finite differences, right? And we had, in my lab, we had a bunch of researchers following that path. But my research director got funding to explore artificial intelligence, because he had that idea that, this looks promising, right? And the interesting thing I found in the end is, and it still fascinates me when I look back, that we showed you can actually measure the velocity of fluid flow using nothing but pattern recognition.
On a
So,
picture.
yes, so, you know,
crazy.
fluid flow is really hard.
Yeah.
But it's well understood, right? It starts with the Navier-Stokes equation, right? So you can use finite element or finite differences to solve for it, to at least come up with approximate solutions, right? But for this particular problem, we applied AI to just find particles from images, right? So it's pure pattern recognition. You use AI to find a particle in the first frame. No, you capture a particle in the first frame. Then in the second frame,
Difference.
you find it, and once you locate it, you know the starting point, end point, and the time difference. So velocity is trivial. But looking at the time, I didn't really think it was a big deal. But looking back, it's really interesting. It still fascinates me that we can solve such a hard problem using nothing but pattern recognition. Right? There are other problems in mechanical engineering that are solved by at least partially solving the differential equation and then using neural networks to finish off.
That's awesome. Shawndra, we want to get you in to see, because your research was really interesting too. It had to do with social and TV
That's
stuff.
right.
Tell us
That's
about
right. So now I focus on television, but back in my PhD, I actually the title was like deriving value from social networks, and I actually got a PhD from a business school. So I did very applied machine learning work, utilizing social networks, and this was back in the day before Facebook and before Twitter.
Holy
so
cow.
the social network data, I know, if you can imagine, right? Remember, so the data that we had were data from telecom, and basically the networks were formed by people making phone calls between one another,
goodness.
and then we, tried to utilize the networks to do things like target marketing to people, fraud detection, and found that the social networks are extremely valuable. So first of all, you are who you call, like you are who you communicate with, so you have a social network signature, and also the people that you communicate with, for the most part, within most contexts, are like you in some way.
Right.
So to the extent that I know something about you, I usually can make inferences, pretty good ones, about your friends as well. So I developed this approach for social network-based marketing, which now, because of all the social network data that we have, has become pretty mainstream.
I mean, can you imagine like having the data that is available now back when you were doing research?
I can't imagine.
She's like, I can't imagine. You can do it now. So that's awesome. Well, I wish we had more time because I could talk to you folks for hours. I love machine learning. I love the work that you do. Thanks so much for spending some time with us. Thanks so much for watching. We are going to have a session coming up next. Again, we're in Nairobi, Kenya for Next Tech Africa 2017. We'll see you after the break. Take care.
Okay, kwaheri.
Awesome.